Hi everyone, and welcome back to Dr. Lem's Learning Lab. Today, we're diving into three statistical concepts that often seem tricky, but are actually super logical. The null hypothesis, the alternative hypothesis, and the p-value. Let's start with a story from a courtroom. Imagine someone is on trial. What's the first thing the law assumes? That the person is innocent until proven guilty. This is the default position. In statistics, this starting point is called the null hypothesis or HO. It's our way of saying, let's assume there's no effect or no difference until the evidence convinces us otherwise. The opposite claim, that the person is guilty, is the alternative hypothesis RH1. This is the new idea we're trying to prove. So we have HO, the person is innocent, and H1, the person is guilty. Now, the lawyers present their evidence: fingerprints, camera footage, witness testimonies. This evidence is just like the data we collect in a research study. The jury looks at all this evidence and asks a crucial question. If this person were truly innocent, how likely is it that we'd see this kind of evidence? And that question is exactly what the p-value answers. It tells us how surprising our results are if the null hypothesis is true. A small p-value, say, below 0.05, means the evidence would be very unlikely if the person were innocent. The jury might then decide to reject the null hypothesis and convict. On the other hand, a large p-value means this kind of evidence could easily show up even if the person were innocent. So, the jury fails to reject the null hypothesis, they can't convict. And remember, failing to convict doesn't prove the person is innocent. It just means there wasn't enough evidence to prove guilt. Just like juries, researchers can also make mistakes. Type 1 error is like convicting an innocent person. We reject the null hypothesis when it is actually true. Type 2 error is like letting a guilty person go free. We fail to reject the null when it is actually false. To minimize the risk of a type 1 error, researchers set a significance level, often 0.05, meaning they're willing to take a 5% risk of wrongly rejecting the null. Now, let's take this logic from the courtroom to the classroom. Imagine a teacher wants to know if using AI for writing feedback helps students improve their English more than traditional teacher feedback. They split the class into two groups. One uses AI, the other gets teacher comments. Before starting, the teacher sets up the hypothesis. HO, there is no difference in writing improvement between the two groups. H1, students using AI feedback improve more. We start by assuming there's no difference. After the study, the teacher analyzes the test scores and gets a p-value. Let's say the p-value is 0.02. This means there is only a 2% chance of seeing such a big improvement in the I group if there were actually no difference. Since 0.02 is less than our 0.05 cutoff, the evidence is strong enough to reject the null hypothesis. The teacher can conclude that AI feedback likely helps students improve more. But what if the p-value was 0.28? That's much larger than 0.05. This suggests the difference in scores could have easily happened by chance, even if both methods worked the same. So the teacher would fail to reject the null hypothesis. There isn't enough evidence to say the AI was better. And this is key. Not significant doesn't mean no effect. It just means our study didn't provide strong enough evidence. So let's quickly recap. The null hypothesis, HO is our innocent until proven guilty starting point. The alternative hypothesis, H1, is the new idea we want to test. And the p-value tells us how surprising our data is if the null hypothesis were true. A small p-value provides strong evidence against the null. Whether in a courtroom or a classroom, Statistics is all about carefully judging the evidence. It's not about absolute proof, but about asking, how surprising is this result if nothing special were happening? That's the heart of smart, evidence-based thinking. Thanks for watching Dr. Lem's Learning Lab. If this helped clear things up, please hit that like button, subscribe, and share it with anyone who might find it useful. See you next time.